Hi, boys and girls. How are you guys doing? Give me a thumbs up if you're having a good day so far. Awesome. I hope you guys have had a wonderful week, but I want to ask something. Did anybody try out any of their magic tricks since I saw you last? Ooh, I see lots of head nods and lots of thumbs up. If you did try them out, thumbs up, thumbs down. Were you able to trick some people? Oh, awesome. Well, I'm so glad that you were able to take all the fun we did here at Mad Science and you were able to show it to someone else. Now today, we are talking all about these really cool things called forces. But before we can get started, I have my 3 Mad Science rules. My first one is that I'm going to be in control of who gets a chance to talk and who is going to be on mute. That way we just make sure that we don't have everybody talking all over each other, because then we don't know where the awesome information is. And I want to make sure everybody has a chance to share their awesome ideas. So give me a thumbs up if that sounds good. All right, my second Mad Science rule is you guys once again have a bag of really awesome materials that we are going to use. Until I say that you need them, go ahead and just leave them off to the side for now, and I'll let you know when you need those things. Give me a thumbs up if that sounds good. Now my last Mad Science rule is my most important one. Does anybody remember what it is? Ooh, let's see. Grayson, what is our third Mad Science rule?
Have fun.
Have fun. You are absolutely correct. Good job. Now, we are going to have a ton of fun. So what we are going to do, pop that back up there, is we are going to talk all about forces. So while I'm getting this switched back over to me, what I want you to do is I want you to stand up wherever you're at. You can stand up behind the table you're sitting at, or if you just want to step off to the side, if you're sitting somewhere comfy, just somewhere that you can stand. Awesome job. Now, what I want you to do is I want you to jump as high as you can. All right, I'm going to count to 3. And on the count of 3, I want you to jump as high as you can. Are you ready? Ready? 1, 2, 3. Whoa, I saw lots of high jumpers. But do you think that you could jump even higher? All right, everybody get ready. 1, 2, 3. Ooh, thumbs up if you think you got a little bit higher that time. All right, let's try it again. Get your best jumping stance ready. Ready? 1, 2, 3. Oh my goodness. You guys did an excellent job. But this time, I'm going to give you one last challenge. I want to see if you can jump so high you can touch the ceiling. I want you to get your mind and your body ready to see if you can jump and touch the ceiling. Are you ready? Ready? 1, 2, 3. Oh my goodness, awesome job. You guys can sit back down. But thumbs up, thumbs down. Were you able to touch your ceiling? No, nobody was able to touch their ceiling. And I'm sure if I jumped as high as I couldn't touch mine either. But what you guys were doing is you guys were using some forces. Do you guys say forces? Now, forces are all around us, but you had 2 forces going on when you were trying to touch your ceiling. Does anybody remember what we called it, that force that's pulling us down and holding us onto the ground? Eric, what is that force?
Gravity.
Gravity, you are absolutely correct. You are using some gravity in order to hold us down. But we also had a force that was pushing us up. You guys were using your own force in your legs and in your body to push yourselves up against gravity. Now everybody take your hands and I want you to hold them close to you like you're about to double high five somebody. And I want you to go out like this. And I want you to say push. All right, do it one more time, push. Good job. Now take your hands and make them fists and pull them back to you. And everybody say pull. Ooh, good job. A force is a push or a pull that happens on something. Now, have you guys ever had a game of tug of war? Give me a thumbs up if you've ever had a game of tug of war. All right, let's take a look. I see lots of people who have done tug of war. Can you tell me what happens during a game of tug of war?
You pull and you push.
How? Do they hold on to anything that they pull and push on?
Like a rope.
A rope, exactly. So you are pushing and pulling on a rope. Can anybody else tell me maybe how you win a game of tug of war? How you would win a game of tug of war. Dawn, how would you win a game of tug of war?
By pulling the rope.
By pulling the rope. What sometimes happens when one team's pulling on the rope really, really hard? What happens to the other team?
They fall.
They fall down. So when we think about a game of tug of war, we are thinking about the fact that I have two teams, each pulling in different directions. Now, give me a thumbs up. Have you guys ever done a game of tug of war where it felt like no team was moving any direction? You were almost standing still? Well, I've definitely seen that. And that's when my two forces, you're pulling the exact same amount, even though it's happening in two different directions. But as soon as one team pulls a little bit harder than the other, you are able to win. Now, all of what we're going to be doing is talking about forces, those pushes and those pulls that we have all around us. Now, inside your handy dandy toolkit that we sent you, you should have a dowel rod. It's made out of wood in there. Go ahead and grab that for me.
I don't know where.
If you happen to not see one of those, you can also use something like a ruler or a pencil if you have one handy, but everybody should have one of these in their packets. Now your challenge is we are going to see if we can balance this rod right here. Right? What I want you to do is I want you to have it sideways or horizontal, and I want you to see if you can balance it just on one finger. Kind of like this. I'm going to give you just a few moments to try that. See if you can take this dowel rod and balance it. That way it doesn't wiggle and it doesn't fall off. Now I see a lot of different techniques. Make sure that you're not squeezing it, but that it's just balancing on your finger. Ooh. We've got some almost Jedi masters on the force over here. Man, good job. Now, can anybody tell me about where their finger is on their object? Is it towards the left or towards the right or in the middle? Where is their finger on their rod? Where is it?
It's in the middle.
In the middle. Thumbs up. Did everybody else pretty much figure out that it was right in the middle where it balanced? You guys are absolutely right. When I think about this, it's kind of like my rope in tug of war. I can either have gravity pulling down on one end or pulling down on the other, but if I make it so they're perfectly equal, it's not going to be pulling down on one side more than the other. But sometimes things are not always equal. One of the things we asked you to come with is a little bit of clay or Play-Doh. So if you happen to have that, go ahead and grab it. All right, you're gonna wanna make just a tiny little ball like this. And what you're gonna do is you're going to stick it on the end of your rod, just like this. If you don't happen to have any, that's okay. This is absolutely an experiment that you can try later on. Another way that I've done this experiment is I've taken a little bit of string and looped it around and hung little weights from it to give it some. But now what I want you to do is I want you to try the exact same thing. I want you to try to balance it on your finger. That way it stays nice and equal. It's not wiggling one way or another and it doesn't fall on the ground. Let's see if you guys can figure out how to get that done.
Hard.
Eric, try moving your fingers. That way it's just sitting on top of it and not in between them. Ooh, looking good, guys.
Oh.
There you go.
Ooh, I see lots of people. Is it harder than you thought it would be?
Yes.
Yes, it is definitely harder. Now, is your finger closer to the end without your clay or closer to the end with your clay?
Closer to your clay.
Closer to your clay. That's because we have changed where the weight is. Gravity is one of those forces where weight is really, really important because gravity is going to pull on things differently if they weigh more or if they weigh less. But what you guys just did is you found something special. You found what we call the center of gravity. Can you guys say center of gravity?
Center of gravity.
What that means is the forces are pulling on it equally. But that may mean that we have different supports, different places. You can go ahead and take these items and you can put them off to the side. I want you to go ahead and stand up behind wherever you're at one more time for me. Now we're going to see if you can find your center of gravity. So make sure that your feet are flat on the floor, making sure that we're doing this super safely. And what you're going to do is you're going to stand on one foot. Take your foot that you lifted off the ground and try and touch it to the inside of your knee and see if you can balance. Now, I want to know if you think that sticking your arms out like this would balance you more or like this. Try it a few times to see if you can find your center of gravity.
Or does it help to have your arms stick out? Or does it help to have your arms stick out?
Ooh, I see a lot of people trying some different things. All right, switch feet. Try standing on the other foot and see if that changes your center of gravity, whether you have your arms out or you have your arms in.
Look.
Ooh, we got some people who are having some good balance. I like it. I got a few friends who are wobbling, and that's okay. Scientists are always trying things, and if it doesn't work the first time, we're going to try it again and again and again until we get the reaction that we're hoping to find. Now, give me a thumbs up if you think it was easier with your arms straight out like this. All right, give me a thumbs up if you think it was easier with your arms in like this. Well, I want you to think about when your arms are out like this, it's kind of like you're that rod, all right? If you start to lean this way, which way is gravity going to start pulling you? It's going to want to pull you to the side you started shaking or started leaning, whether it's this way or that way, which might make it more likely for you to fall. But if you put your arms tight and close to you, gravity doesn't have as much to pull on you, so you're making your center closer. Now, so for some people, this does help if you can keep your arms nice and straight and at the same level. But if you pull them in like this, you're giving gravity a little bit less space to work on. But we can find center of gravity all sorts of places. You guys can grab a seat again. Good job. Now, I'm about to show you a couple of close-up experiments. That way you guys can see how we use our center of gravity. All right, we're gonna switch on over here. All right, so what I have here is called a gyroscope, all right? And what it is on the inside, I have a little wheel that spins that's attached to this column right here. But on the outside, it has a frame that it is not connected to at all. So I could sit here and I could spin this and it's not going to spin my wheel, or I can spin my wheel and it's not going to spin the outer frame. Now what this is doing is it's using the idea that forces can go in any direction. It doesn't just have to be up and down, it could also be side to side or in any direction really. So what we're going to do is I'm going to take my gyroscope. What I have tied here is a piece of string. What my force is going to be is I'm going to pull on the string. And when I pull, I'm going to cause this wheel in here to spin. So when I take it, I put it like this. Oh. Now, the great thing about these things is they're really super nifty, but they can be a little temperamental. So sometimes if the force is too much, it can actually pop apart, but we've got a spare one right here. See if I can use a little bit less force this time. See if we can't get it to stand up on its own. Now what's happening is I put that force not on the outside frame, but actually on the wheel itself. And that wheel, it's pushing towards the outside as it's trying to use up that energy that I put into it. And it's going to keep going and going and going until it either falls off my table or it runs out of that force, that pull on the string that I put into it, and keep going like that. Now, this wheel, it's not connected. So I have to know about the forces around me. I know that gravity is pulling down on it, but I also know that there's this stuff called precision. Can you guys say precision?
Precision.
And that just means that as I'm moving that wheel, that constant movement is what allowed it to keep spinning around on my table. But I have another experiment that I want to show you, and I want to know how you guys think that I could do it. Here I have just a regular old plastic cup, and I'm going to put just a few coins in the bottom of it to make sure that it doesn't fall over while I'm doing my experiment. What I'm going to try and do, I'm going to try and balance these two forks on my cup without my forks touching it. Does anybody have an idea of how I might be able to do that? How I could use my cup, balance my forks on it, but not have my forks touch it? What do you think? How could I do it?
Maybe you could use those coins, put them on the rim of the cup, and then you can balance the two forks on it.
Ooh, I like that idea. Does anybody else have any other ideas? How can I get my two forks to balance on my cup? What do you think I could do?
You could, on the edge, like when it goes like down, then up, and then straight, you could put it on the cup and try to balance it.
I like that idea too. Well, what we're going to do, knowing about my forces, is I'm going to see if I can't balance it. So what I'm going to do is I am actually going to take a nickel. All right, the bigger the coin or the bigger the surface you have, the easier it's going to be. And what I'm going to do is I'm going to take it and I'm going to put it in between the teeth of my fork. Now, I'm not going to make it halfway. I'm going to try and leave as much of that coin in front of my fork as possible. Then what I'm going to do is I'm going to take my other fork and I'm going to slide them together. That way they hold on to each other. Now, just like the rod that you were doing earlier, is I have to find that center of gravity. So I'm going to slowly take my coin and see if I can't find where it's going to have enough to hold the weight of my forks, but also not fall into my cup as I try and do it. Now this is one of my favorite experiments, but this is probably the experiment that I personally don't get to work a lot of the time. And that's all right, because some scientists are better at one type of science than another. So I like to give this one a good try, but if I can't get it, I highly encourage you to try it out for yourselves at home. Almost. And there we have it. I'm going to move you guys just a little bit, that way you can see what is going on right here. So you can see that my coin is just balancing right on the edge of that cup. My forks aren't touching it. You guys saw I put together this while you guys were here. There's no trickery or magic behind it. But the one thing you also have to think about is on the outside of coins, they have a little rim on them. So that little rim is helping hold on to my cup. But the most important thing is that I found its center of gravity. Even though I had more weight on this side with the forks, I found to where gravity was going to hold on to it the best. So that's an activity that you can try all sorts of ways at home. I used plastic forks. You could try metal forks. I used a nickel. You could try a quarter or a dime or a penny and see if that changes the way that this experiment works. The one thing I will say is that if you're using a really light cup, make sure you put something in it just so the cup doesn't tip over when you're trying to do that experiment. But gravity and all the forces around us are really, really cool because they don't always work in the same way. Can anybody think of another place that they've seen something push or pull on the world around them? Let's see. All right, what do you think?
With earthquakes,
Ooh, earthquakes. What happens in earthquakes?
the gravity and pushes and pulls are forcing the Earth's surface to go on top of each other and under each other.
Yeah, they might be pushing together or pulling away from each other. That's a great example. What's another way or a place that we see pushes or pulls in our world? Sometimes it can be hard to think about. I know sometimes when I'm put on the spot, it can be hard. But let's see what we got over here. What do you think?
Like when you're playing tug of war with like a rope and you try to pull the other team down, that's sometimes like you're pulling back and forth and you're trying to get the rope onto one side.
Yeah, absolutely. But I have a question for you guys. Have you ever seen the videos where they were dropping things off of like the roofs of buildings and seeing what happened when they landed? Well, that is one way that we can be doing science where it doesn't really feel like science. So what I'm going to do is I'm going to do the same kind of thing. I'm not going to drop anything off my roof, but I am going to drop two different objects. Right here, I have a squishy Nerf ball, and right here is I have that same clay ball from earlier. I want you to give me a thumbs up or a thumbs down. Do you think that these are going to react the same way when they hit my table?
Mm-mm.
No? You think they're going to act differently? Well, let's test it. If you have clay, you can also try this by doing a larger piece of clay and a smaller piece of clay. So you're welcome to try it with me if you would like. If not, you're welcome just to watch. What I'm going to do is I'm going to start with them from the same height, and then I'm going to drop them. All right, we're going to do it one more time. See if you can watch the difference in what's happening between my large squishy ball and my smaller clay ball. 1, 2, 3. Thumbs up, thumbs down. Were we correct with our idea that they would move differently? Absolutely. And this ball, even though it's kind of hard to see, it did something really, really special. What it was able to do is it was able to form back into its original form. It's squishy, and so when it hit it, it was able to bounce back and keep its form. But on here, this one formed kind of a flat side on it. This one, it doesn't have the same characteristics. So it hit my table, and it wasn't able to reform itself. So the materials and the weight that it's made out of also affects it. Now, even though this is a larger ball, my clay one is actually heavier. It has more mass to it. Can you guys say mass?
Math.
Mass, so it's gonna interact differently. You'll notice it didn't bounce as high either. So depending on how much something weighs and what it's made out of is going to affect the way that it moves. But I'm about to show you one of my favorite activities of all time. And after I show you and I give you the question, I'm gonna pause for just a few seconds and I want you to think about how you would complete this before I show you the trick to the activity. Now what you're going to do is I have a stand just like this. This right here is called a bolt. You would use them if you were screwing together like really big beams of wood or even some metal structures, but I've just drilled it into a block right here. But the challenge is I want to take all of these bolts and I want to balance them on the tip of this bolt. So here I have a lot of other loose bolts, but I want to balance them on the tip of this bolt right here. So I'm going to give you just a few seconds and I want you to think through and maybe tell somebody next to you, how would you do this? And then I'll take a couple examples before I show you the trick behind this activity.
I know how she's going to do this.
I don't know. We can show them something.
Did you guys get a chance to think about how in the world I'm going to balance all of these on top of my bolt right here? Let's see, I've got one hand raised. Let's see what he thinks we're supposed to do. How am I going to complete this?
I think that those edges that go into the wall or whatever you're putting it into, I think you could probably like kind of push them in at like an angle and they would attach to the bolt.
Okay, so maybe they would attach to it. Well, they're both metal, so they're really, really strong. So I've tried that, and I won't be able to push them all together, but that's a really great idea. When scientists are coming up with ideas, they call those hypotheses. Do I have anybody else who has a hypothesis about how in the world I can get all of these bolts to stay on top of my other bolt? And it's okay if you don't. This is one of those like, oh, let's see, we got one over here. All right, what do you think I'm going to do?
Like the one that's in the wood, and the thing on top, you're going to stick the sharp part in, and you're going to keep doing that until it's the bolts are all gone. Like when you run out of bolts.
Okay, let's give that one a try. All right, so what he was saying is I'm going to take this one right here, and I'm going to stack them kind of like this, right? Is that what you were thinking? No.
The sharp part in there.
Oh, like this? Well, if I could find the center of gravity and be perfectly still, that might work. But what I can also do is I can use the idea that I know the gravity wants to pull everything to the ground. So what I'm going to do is I'm going to start with one bolt and I'm going to lie it flat on the table. Then what I'm going to do is I'm going to take, this is called the head of the bolt, and it's got a little lip or rim on it, and I'm going to stick it so it's lined up on that bolt. But then what I'm going to do is I'm going to go every other one on which side it is on until I have all of them used up.
I did it.
So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bolts that I've crisscrossed, and then one on the bottom. Then what I'm going to do is I have the one that I laid flat, the head right here. So I'm going to lay this one the opposite direction. So the head of this one is on this side. And when I grab my two that are laying flat, all of the bolts are actually going to grab onto those two ones that I had laid sideways. So what I can do from there, I can bring this back over here, and I want to find the center of gravity. I want to know where I set it on here, how it's going to be equal on both sides. it. We're gonna right in the middle.
Yeah, come and see this.
And I'm able to balance all of them on top of that one single bolt.
Look at
Now, what you might not be able to see, and I will flip you guys around,
no, she said 12.
is you can see how the heads have grabbed onto, but I'm not gonna have grabbed onto those ones that I made go side to side.
Bad copy
So
breath.
by knowing that they would grab onto from the gravity that's pulling them down, they're able to stay on top of there. And when I found the center of gravity, I was able to make it so it wouldn't fall to one side or the other. Now this is my favorite activity because I know that for a really long time, nobody told me how to do this activity, and it drove me crazy trying to figure out how in the world I would get all of these to balance. Now I had the same idea as somebody did earlier of let's try and stack them all, but I quickly realized that there just wasn't enough consistency or the same things happening on all sides for me to be able to do that. So by understanding how the forces are working, I was able to figure out how to get it to balance like this. Now this next activity is something that you can do alongside me. We're going to want to grab your dowel rod one more time and that little ball of clay you had and stick it on one end. You guys will grab that for me.
Wait, Cissy, I'm gonna use it like not as
All right. Now what I want you to do, boys and girls, is stick your hand out flat just like this. And your palm right in the center, usually the flattest part, is you can stick it. And I want to see if you can balance it. I'm gonna use a little bit of a larger one with a tennis ball just to show you guys, but it's the same exact idea. I want you to see if you can put it in the middle of your palm. And see if you
Why
can
is tennis ball?
seeing which end, without grabbing onto it, it would be easier for you to balance or find that center of gravity. Take just a few moments and see if you can try that out.
Got it.
I'm thinking it's flat this.
Let me try. I'm gonna use this.
Watch the top of it.
Well, I see you guys doing a really good job. Now the hardest part for sure is when you have the end that has the extra mass on it, your clay, is making sure you don't try and grab it, because then I'm not really using gravity or my forces. I'm just using the fact that my hand is holding onto it to keep it balanced. I'm making sure that your hand stays nice and flat while you try that on.
You want to wait on the. So you
You
watch
guys
it.
are doing a good
Using
job.
a marker.
Now, one way you can do this activity again and again is change the size of the item that you put on the end of your dowel. Use a smaller amount, use a bigger amount. The way that we do experiments is we try the same thing but in different ways to see if we get the same or a different ending. So I'm going to give you just about 30 more seconds. Try it one more time on each side.
I just figured it out.
Balance it with just the rod in your hand.
Yeah.
You can balance it with the weight in your hand.
Way too heavy. Can I use this then?
No, look.
Can I use that? I need to put it.
I just made it flatter. I just made it flatter so it could just stand.
Oh, I like that idea. Now, I don't know about you, but I found it was a lot easier when I had the mass or the clay ball in my hands. Give me a thumbs up if you agree. The reason that is because when I have my mass floating up here in the air, I have less control over it. So as soon as gravity starts to pull in one direction, it's going to want to try and fall on the ground. But I have something that you've maybe seen before. Eric, do you have a question?
What I like to do is I like to just take off take a little bit of the clay then I just let the rod slide to my fingers, then I just snap them shut. That way it kind of wiggles, but I can do it.
Very cool. So that's the great thing about a lot of the experiences we give you is you can try it lots of different ways and see what makes it easier and what makes it more difficult. Now, go ahead and take those items and put them off to the side for me. I'm about to show you something, and I want you to give me a thumbs up or a thumbs down on whether or not you've seen something like this before.
It's me, taco.
Take a look at that. See if you recognize maybe what that is and if you've ever seen it before.
I've seen it. Look, like that. What is it? It's like a. I don't remember the name.
What is this?
It's like that thing where you drop pennies in and it goes round and round and round.
Absolutely. So this we like to call a coin fountain. All right.
Yeah.
So our coin fountain, what it does is I heard somebody say it, a funnel. And I've got two spots right here where I can help guide my coins, and they are going to go down here. So what we're going to do is we are going to look at how these coins move. So I'm going to use a nickel and a penny for my first activity, for my first trial of this, and we're going to see how they move. Right, what we're going to do, we're going to turn you guys around, right? And what I'm going to do is I'm going to start my penny up here, and I want you guys to watch how it moves. Now, thumbs up, thumbs down. Would the same thing happen if I just stuck it right here and let it go?
No.
Let's get it.
Nope.
Nope, it didn't happen in the same way. So what we have is we have another special kind of force. Can you guys say centripetal force?
Centrifugal force.
All right, centripetal force is pushed inside. So when I think about centripetal, it's got the word center at the beginning of it. So all the while, my force is pushing it towards the center. Now I'm going to start 2 pennies, and we're going to see how they move. Going different directions. Even as it got all the way down to the bottom of the funnel, it continued to spiral or use that centripetal force. Now what I'm going to do is I'm going to use a penny and a nickel, and we're going to try and do them at the same-ish time to see how they move. Because do a penny and a nickel weigh the same amount, can you think?
No.
No, which one's lighter?
No.
Penny.
Nickel.
Penny's lighter. See the penny went down. That was the nickel down. No, she put the nickel down first.
What was that?
So as I moved them, they moved in 2 very different ways. My nickel took a lot more time to get there because it is not only larger, but it also weighs a little bit more than my penny does. But I have another thing that I feel like you guys might have seen before. So when I show you, give me a thumbs up or a thumbs down on whether or not you know what this next item is. Do you guys know what this is?
I think I know, but I'm not sure.
Just say,
Quiet, Bailey.
What do you think this is?
well, it looks like it had like a car on it. And
I might have a car on it.
it looked like one of those Hot Wheels sets that goes all the way around.
Well, you guys are absolutely correct. This is a Hot Wheels track. And what happens to my Hot Wheels? Does it just go in a straight line? Or does it go up and around my tracks and then back down?
Up and around and back to the track.
It goes up and around and then goes to the bottom.
Yeah, we're gonna give it a try. So what you guys maybe can't see so well from that angle is I actually have 2 batteries that are going to power a motor. I could use my hand to be the force and push this around, but I know that I don't have enough. So I'm gonna use the help of my motor that's gonna help move it, and we're gonna see if we can get it to go all the way around. Now, did it make it all the way around my track?
I don't know.
All right, let's take a look one more time. Look really closely.
No.
All the way around?
I can't see it. I'm still
You can't
like,
see, you're not spotlighted.
Oh, here we go. There we are. Let's try this again. All right, turn on my motor.
Oh, yes. No, it didn't. It
Am I working it all the way around?
it went up and off.
Yes.
It kind of fell off right about here. So what I know is my motor, it gave a push to my Hot Wheels car, and using that centripetal force, or that inward push, it was able to get it to about here. But I didn't have enough force to get it all the way back around and down. Have you guys ever ridden in anything or seen anything that has a similar loop shape like this? What have you
A
seen?
roller coaster.
A roller coaster. If you've ever ridden a roller coaster, go like this, like you're riding a roller coaster. A roller coaster uses the exact same science as our centripetal force. Usually you go up a high, steep hill, and then you go down before you go into a loop. That's because you have to get enough of that push to get through that entire loop, and it's what helps hold that car onto the tracks. So forces, like I said, can be anywhere as simple as me jumping up and down, all the way to me riding a really fun loop-the-loop roller coaster. Now I have another activity that I would like to show you, but this one is something that if you have the materials at home, we didn't ask you to have them, but if you do, you can also try. So what I have here is I have a regular old balloon. And what I've done is I have put something very special inside of it. I have put is what is called a nut. And what happens with a nut is something that you might screw onto like a bolt. That way, you can hold it all together, but I'll show you guys. That's what a bolt looks like, or a nut, I mean, excuse me. And what we are going to do is I have put one in here. You can see it right there. What I want you guys to do is I want you to listen really, really closely as I take this and I'm going to spin it like this. It's not as important that you watch what's happening, but I just want you to listen. And give me a thumbs up whenever you hear something. Did you guys hear that?
Yeah.
Yeah.
So I'm going to do it a little bit slower in this way. So what you can see is my nut is actually going along the outside of my balloon. I'm creating that centripetal force that's pushing it to go around. But that sound that you hear is actually air pushing through the nut right there. So as I do it, I've got a couple things happening. You can see it right there. So even inside a balloon, I can look at the way the forces are reacting. Now, that's a really easy one that you could do at home. You could also use it with something like a penny or a little plastic bead or marble. You won't get the same sound because you don't have that air whooshing through the middle of it, but you get the same effect. And you can actually have somebody put their hand on it if you're careful, and they can feel where that nut is going all the way around their balloon. Now, what I want you guys to do is inside your awesome bags, you should have something that looks like this. Go ahead and grab that for me. Right? When you pull this out, just make sure you pull it out gently because there are some smaller pieces.
I had it.
Those smaller pieces should be in a little tiny bag.
And the first thing you're going to want to grab is this piece right here. Now, the important part is we've got that piece of sticky tape right there again. You're going to want to make sure that you fold over really good. That way that part becomes bendy. Because what you'll end up doing is when you fold all the creases, you're going to make a little pyramid. If your sticky tape is not all that sticky, like last time, you can always use another piece of tape on there to make sure you hold it nice and tight. The other thing is on my tip, sometimes if we don't line them up just right, they might not be the same height. You want that to be as flat as possible. Make this work the best way possible. And if you need a hand, or if you need a little extra help, just raise your hand and I will spotlight you and I will give you some help. Yes, ma'am.
I don't know if it's supposed to be like this when it like opens up.
Yes. That is just fine.
Okay.
All right, anybody else? Everybody's got it pretty good. As soon as you have it all put together, go ahead and give me a thumbs up, just so I know that you've gotten that part put together. If you've already got that done, the next thing I want you to grab is the two birds like this. Your goal is going to be able to find the center of gravity for all of these objects. So we've got a friend right here who has already found that center of gravity, figured out where she can set it on her pyramid, and we need balance.
I did the eagle too.
Nice. Right? My favorite one is probably the soaring eagle, because its center of gravity is maybe not where you thought. So once you got the two birds to balance, try the soaring eagle.
I got the soaring eagle. Ooh, next one's a spaceship. Ooh.
You guys are doing a really awesome job. I went ahead and muted you, just so that way in case anybody has any questions, I can make sure that I can get their questions answered, but you guys are doing a rocking job. Say, if you want to try something else other than the soaring eagle, like the snake, or I guess that's a rocket ship. You guys have a slime and a rocket, and you have the pizza. Now the pizza is really cool. The key is don't bend it. But as soon as you get it balanced, you've got a little bag full of pizza toppings that you can use to try and balance it out once you have it on there. Now, there are also 3 little numbers on your pizza. Try to put that number on the tip of your pyramid and then balance the rest of it out with your pizza toppings. Ooh, we got a lightning bolt that's standing up. That's really awesome job you guys are doing.
Let's just do the most.
You're balancing, or is it stuck down in there?
It's a bit stuck down there.
Gotcha. See if you can find one of the sides where you can get it to balance, or maybe the other end of the lightning bolt.
And the trick is with the lightning bolt. Just point the sharp part down.
So the key with the lightning bolt is you don't want your lightning bolt to just stick inside a little hole. You actually want it to balance. So always keep that in mind with some of those ones that have sharp edges. Yes, Eric.
The key for the pizza is you can balance it with no toppings. How? You just don't finish the pyramid and make it look like this. And then you just put the pizza on top. And it will balance. If you put any toppings on there, it won't balance. The first time I did it, it succeeded. So that's why I recommend that for the pizza.
I see. I like that you're thinking a little bit out of the box. and trying something different. Okay, I'm just gonna sit and watch you guys for a few moments while you experiment and figure out how to find the center of gravity for all those things.
Actually, I'll make you guys a pizza.
Me too. I'll make you guys a pizza.
Hey, what kind of pizza would you like? Mushroom or pepperoni?
I'll make you some pepperoni. I had it last time.
I think it was one of this.
Hey, electric. Aaron, would you like a pizza?
I would love a pizza, but I want to show you guys something real quick. Now, I didn't put my pyramid all the way together, but the story, his point or center of gravity is actually on his beak. So if you guys weren't able to get him to work, try it from his beak.
I wanted to show you really cool.
I know. Do both of them?
It might be for better days, but you should be able to yours get it to where he. Oh, there we go. We got it for a second.
I brought it.
Balance from the tip of his beak.
That's magic.
Yeah, it is kind of like our magic.
I can do it.
But the reason it's able to do that is because his tail feathers are not that heavy, and then his wings are equal on both sides. So I know that when gravity's pulling down on it, as long as it's on that center point, it's going to balance. I could even try and move it back here, but then my wings are too heavy, and then obviously from either wing, I'm going to have too much mass or weight on either side. Now, you guys, we sent out an email earlier today, and you guys should have also been asked to find us another material. I have a video that I would like to show you because it's another example of how you can use centripetal force when you are looking at different experiments. So I'm going to play you guys a video real quick. So that's an experiment that you guys will be able to try yourselves. What I'm going to do is your parents should have gotten an email that has the link, but I'm also going to drop it into our chat box. So you can always copy it from in there. That way you guys have it right away. But what they were doing is they used those straws to draw up the water, and then when they cut the corners off and it was able to push it through, it was using that centripetal force, kind of like our loop-the-loop or thinking about how a roller coaster works. So I'm going to make sure that you guys get that information, but I'm going to give you guys just a few more minutes to play along. But what I want to know before we get off is I'm going to ask everybody what your favorite experiment talking about forces was today. So as I get you guys that link, I want you to be thinking about which experiment you thought was the coolest. Do I have anybody who wants to go first and tell me what they thought their favorite experiment was from today? Ooh, lots of hands. All right, what was your favorite activity from today? And make sure to unmute yourself.
Balancing the eagle.
Nice job, dude. Well, what was your favorite experiment from today?
The one you made a roof with the drill thing.
With the bolts, getting one to balance?
Yeah.
Yeah, that one's definitely one of my most favorites. Who else wants to share what their favorite activity from today was? What was your favorite activity?
Mine was the balancing of the eagle.
The balancing of the eagle, absolutely. What was your favorite?
This one too.
The take-home activity, that one is pretty awesome. What was your favorite activity?
Is when you get to do first the math science and then you can take it off and then try to do the eagle. And it's so fun to try to get the eagle to balance by its beak.
Good. Do any of my other mad scientists here want to tell me what their favorite one was? Go ahead.
What I enjoyed was my most favorite one is when we all got to share when we got how we balance stuff.
I know. I love the fact that scientists, we always share our experiments. We share what we're learning, what worked, and what didn't work. Does anybody else want to share what their favorite activity was?
Care for a pizza?
Well, I'll tell you, my favorite activity was watching all of you guys at home try each and every one of these activities. So awesome, awesome job. The one last at-home activity I wanted to tell you about is I want to challenge you and to tell me when you come back next week some different items that you found the center of gravity for. It could be a pair of scissors. It could be a shoe. Find some different things around your house, making sure that it's safe and not going to break if it falls. But see if you can find, by using that one or two fingers maybe, what the center of gravity is. I'm going to hang out here for just another minute, but otherwise, I will see you guys next week.
See you guys next week. Goodbye.
Bye.